armature control DC motor is used as an actuator where position control and velocity control both are equally important. Considering the linear zone of operation, it has three different parts: electrical circuit, electromechanical circuit and mechanical circuit. In case of electrical circuit, the equation of dynamics can be written using KVL. So, the equation of dynamics is RA times IT plus LA times ddt of IT plus the back EMF Vv is equal to the applied voltage. Now, the current in electrical circuit will produce torque through the electromechanical circuit. So, the expression of torque tau t is equal to kt times it, where kt is the torque constant. The produced torque in electromechanical circuit will support the rotational load in mechanical circuit. The angular displacement is theta t and the angular speed is omega t. Here the inertia is J and the viscous friction coefficient is B. The equation of dynamics of mechanical circuit is J times ddt of omega t plus B times omega t is equal to the torque. Now, using these three equations, I will derive a relation between input, that is the applied voltage, and the output, that is the angular displacement. Putting the value of torque from equation 3 to 2, we get the current IT is equal to 1 by kt times J ddt of omega t plus B times omega t. This is equation number 4. Putting the value of current from equation number 4 to equation number 1, we get LA divided by KT multiplied by ddt of J ddt of omega plus B omega, we are omitting the T, plus RA divided by KT multiplied by J ddt of omega plus B omega plus the back EMF KB into omega equal to Vt. After simplification, LA times J divided by KT multiplied by double derivative of omega plus LA times B by KT ddt of omega plus RA times J by KT ddt of omega plus RA times B by KT omega plus KB times omega is equal to Vt. Now we will equating the coefficients of differentiation. The coefficient of second derivative of omega is La times j by kt. Coefficient of first derivative of omega is La times b by kt plus Ra times j by kt, and the coefficient of omega is Ra times b by kt plus kb. Again that is equal to Vt. Now making the coefficient of highest derivative is equal to 1, we get double derivative of omega plus La times b by La times j plus Ra times j by La times j ddt of omega plus Ra times b by L times j plus kb times kt by La times j omega is equal to kt into Vt. Assuming Ra times b divided by La times j plus kb times kt divided by La times j, which is the coefficient of omega, is equal to A0. La times b by La times j plus Ra times j by, which is coefficients of first derivative of omega, is equal to A1, and kt equal to b, we get double derivative of omega plus A1 first derivative of omega plus A0 times omega is equal to b into Vt. It can be also written as omega double dot plus A1 times omega dot plus A0 times omega is equal to b times Vt. This is equation number 5. Now choosing the value of A0 is equal to 2, A1 equal to 3 and b equal to 1, from 5 we get omega double dot plus 3 omega dot t plus 2 omega t is equal to ut. We are assuming Vt is equal to ut. This is the dynamical equation of armature controlled DC motor, considering voltage is the input and angular speed is the output.